All right, we're back. Okay, so our next example basically has us, you guys, looking through graphs and like basically what's happening to them. Okay, so when we are graphing, we're going to be talking about two main pieces. We're either going to be talking about graphs having a vertical shrink, okay, or we're going to be talking about graphs having a vertical stretch, okay, and I think I just totally mixed up the colors here. Okay, so basically, as you guys can see on the right hand side here, this that's in green, this is when you have an a value that's greater than 1, okay? So that's what's going to happen when you have a vertical stretch. So just think of it like when you're stretching, you put your arms straight up in the air, okay? You don't like necessarily make yourself wider. You want to stretch something. You want it to get closer to your y-axis here. And then when you're doing a vertical shrink, okay, that just means it's going to get closer to the x-axis. So it's going away from your y-axis. Okay? And then just basically down here, they're just talking about the same thing's going to happen, right? So this is going to be considered a vertical shrink right here when it's getting closer to the x-axis. This is going to be getting considered a vertical stretch when it's getting closer to the y-axis, but it's just flipped. So you've got an a value that's negative. All right, so I'm going to try and just kind of somewhat hustle through these because I don't want to make these videos too long. But basically, you guys, so I gave you graphs that have the parent function, this x squared, on them. And we're just going to go through and we're going to graph our new function and we're just going to figure out, okay, is this stretching or is this shrinking? Like, is this getting closer to the y-axis or is it getting closer to the x-axis? Okay, so first things first, we've got our g of x function. So g of x equals 5x squared. We're just going to take these x values, we're going to plug them in. So grab your calculators. When you do 5 times negative 2 squared, okay, so negative 2 squared is going to turn into 4. 5 times 4, that's going to give you 20. And then if I plug negative 1 in, so let's see, 5 times negative 1 squared, negative 1 times negative 1 is going to be positive 1, so that's just going to turn into 5. When I plug 0 in there, that's going to be 0. And then this stuff's just going to start reflecting because that's what a parabola does. It starts reflecting, it starts getting symmetric. Okay, so let's quickly go through. We'll graph. Negative 2, 20 is going to be way up here, probably even further away, but that's all I've got room for. So then I'm going to go to negative 1, and then that's going to be at 5. And then I'm going to be at 0, 0. I'm going to be at 1, 5. And then I'm going to be at 2, and then all the way up here at 20. I'm just going to connect all these dots. Hopefully yours is going to be much straighter than mine. Okay, so let's take a look at this. Is this graph getting closer to the y-axis or is it getting closer to the x-axis? So again, let's take a look. Is that one going to be more like this one that's shaded in green, or is this going to be like this one that's highlighted in yellow? Hopefully you guys are noticing that it's going to be the one more like the green. So we're just going to say that this graph is vertically stretching. So we're pulling it, we're getting it closer to that y-axis. Okay, we're going to do one more example together, then I'm going to have you guys do the next two on your own. And then I'll show you these tomorrow in class. We can talk about them. You can ask whatever questions you need to. Again, we're going to start with our new function. We're going to start with h of x. That's going to be negative 1/3 x squared. Okay, so let's start plugging, let's plug negative 2 in here for that x. When I do that, I believe this is going to turn out to be negative 4/3, or if you say 1 1/3, that's fine too. If I plug negative 1 in, this should give me negative 1/3. That'll just turn into 0. And then these are just going to turn out to be the exact same through symmetry. Okay, so then I'm going to go -2, -1 1/3, so that'll be about right here. -1 1/3, that'll be right here, 0, 0. Then again, that's just going to start reflecting. Okay, so now if we look, there's two things that are happening with this graph. Number one, it's reflecting. So that graph is flipping over that x-axis, so it's reflecting. And then the next one, this is getting closer to that x-axis, so we're just basically going to say that this is a vertical shrink. So those are the two transformations that are happening. Okay, now like I said, I want you guys to try the next couple on your own. If this is going to move for me, why aren't you moving? Okay, so you're going to try for sure these next two on your own because you have these two. If we need a third one tomorrow, I'll graph this one with you too, just so that we get the basic concept. But really, the last thing I want to talk about is this word problem example. So the diagram at the left shows the cross-section of a satellite dish. We've got X and Y, those are measured in meters. Our job is to find the width and the depth. So we want to find this width, and then we want to find this depth here. Okay, so the first thing I'm going to look at is, well, you guys, we've got units, we've got two ordered pairs here that'll help us out. So when I try and get from this side of the satellite dish to this side of the satellite dish, basically, how many units long is it? So from -2 to 0, that's going to be 2 units. And then I'm going to do 2 more units. That's going to be a total width of 4 meters. Okay, then I'm going to take a couple seconds. Let's figure out the depth. I'm starting down here at this origin. And then as you can see, that's going all the way up to here. So that depth is just going to be 1 meter. Okay, and that's all they're really asking you for. The satellite dish is in the shape of a parabola. They just kind of want to, again, get you kind of thinking about it. Again, take a look. This is y equals 1/4 x squared, and that's a really, really wide graph. It's wider than your basic x squared graph would be. All right, I am done. Make sure that you guys get this stuff copied down. If you have any questions, make sure you write them on the left-hand side of your note packet so that we can go back to them tomorrow. And you're all done with your videos. We'll see you in class tomorrow. Have a great rest of your night.